for part of this domain, we're going to talk about really what we kind of the three-headed monster that really drives everything in domain number 1, which is confidentiality, integrity, and availability. There are other aspects of security that we do discuss, but confidentiality, integrity, and availability, that's the triad. That's what we want to ensure, right? Confidentiality means what? It means that I want to make sure that the data that is proprietary or the data that is supposed to be secured stays secured. In other words, only authorized individuals are allowed to see this information. It could be intellectual property rights. It could be personally identifiable information. It could be trade secrets or you know, pretty much anything, right? It could be national security components or whatever. So confidentiality means that the information stays essentially hidden, right? Meaning that if you don't have the key, if you don't have the appropriate security clearance or security level, you won't be able to see that information. We often will employ this process either to data at rest or data in motion. That's generally what we like to look at. But it doesn't have to be just data. It could be, like I said, intellectual property. It could be personally identifiable information, right? Healthcare records, for example, at a hospital, they have to remain confidential. And we'll talk about how we manage that process a little bit later on. Identity theft, you guys know what that is. Assuming someone's identity through the knowledge of confidential information. Pretty straightforward, right? Oftentimes, gaining bits and pieces of information can lead you to actually understanding more and more information about that individual. You know, it could be financial crime, cyber crime. It could be simply to gain access to other information that you're not supposed to gain access to. You guys are aware of this, obviously. To ensure confidentiality, oftentimes we have to classify the information because we apply different levels of controls, administrative, technical, etc., to those data sets based on their classification. So data classification is key to ensuring confidentiality. Data classification doesn't mean that data becomes confidential, right? You still have to implement the controls to make the data confidential, but in order for you to apply the appropriate levels of control, you have to identify the data itself, right? Being with the government, obviously you understand data classification. It's very, very important. Access control methods include identification. So who are you, right? And identification is usually done through multi-factor methods. We'll talk about multi-factor identification and authentication a little bit later on. And then finally, authorization. Authorization is a big component to this because you may have the ability to see information but not modify information. Or you may have the ability to see certain aspects of information but not all aspects of the information. So authorization is what are you allowed to do with that data? Can you transport it? Can you change it? Can you modify it? And so on. Encryption is also an example of confidentiality. A lot of times in cryptography, when we think of security architectures, we think of confidentiality as encryption because it's hiding the information. Right? And we'll get into that in domain number 3. Another aspect of this CIA triad is the concept of integrity. Right? In general, what is integrity? When it comes to data and information assurance. Any ideas? No? You're the only one here, so you get to answer, or somebody online get answer. Integrity means that the data that was presented or created or the original data set isn't modified or changed along the way. Integrity doesn't necessarily mean confidentiality, right? Integrity means that the essence of the information, the concept or the context of the information doesn't change, right? Now, it could be integrity of a transaction. Say I'm going through an online application and I'm depositing money into my bank. I deposit $1,000. Well, I want the bank to see that it was $1,000 that I deposited, not $10, right? If that somehow got changed to $10, that affects the integrity of that transaction. If I send a message to somebody through a data channel, whether it's a text message or an email message or whatever, I want to make sure that the message that I sent is the message that was received. Integrity is not confidentiality, though. The goal of integrity is to ensure that what was sent is what was received, not necessarily that it's hidden. So that it says here in the bullet point principle that to ensure that data is protected from intentional, unauthorized, or accidental changes. So it's not confidentiality. We're not trying to hide the information. We're trying to make sure that the information arrives at its destination unchanged. Along with integrity comes this concept of non-repudiation. Non-repudiation, probably a long word to write there, but non-repudiation means what? Any ideas?
It means that somebody cannot argue that it wasn't that the system would verify that the person that acted on the system was actually indeed them.
Exactly, exactly. And you were saying the same thing, right? Meaning that I can't deny that I sent something, or I can't deny that I was the originator of that information. Non-repudiation of origin is another concept that we'll talk about quite a bit when we get into domain number 3. Another example of non-repudiation, well, it's not really non-repudiation, but we use a similar technical control for this, is digital signature, right? Digital signature is a way for us to identify the origin of information. Well, integrity is kind of incorporated into that process, right? Here's an example, and we'll get into this in the cryptography section, but I want to make sure that we're kind of tying all this together. There are 2 ways that we can ensure integrity and non-repudiation of origin when we're sending an email, right? There's 2 primary ways. There's lots and lots of ways, but PGP, pretty good privacy, and SMIME, right? SMIME and PGP are very similar concepts where we use the public key infrastructure to identify information that's being sent back and forth between through email channels. How does it work? It uses the PKI structure, which we'll talk about in domain number 3, where we have a private and public key pair. Now, if I'm sending you an email, and I want you to know that that email came from me, and I also want you to know that that email hasn't been modified along the way, somebody didn't intercept that message and change it and send it on, how do I do that? With digital certificates, right? But those digital certificates have to be used in a specific way, right? And again, we'll get into this in the cryptography section, but I essentially sign my email with my private certificate, and you verify that signature with your public certificate. The way that provides integrity is that nobody knows what the private certificate is. And again, I'm not going to get into the details now, because when we go into cryptography, we're going to get into all these in a lot of detail. But the principle of integrity is not hiding the information, not encrypting the information, but somehow assigning some sort of signature to that information that allows us to verify that it hasn't been modified. Okay? Could be a file, could be a database, could be systems, it could be network information, could be an email, and so on. All right? Now, there are other aspects that allow us to control integrity, things like segregation of duties. All right? Meaning that in order to launch this missile, 2 people have to turn the key. That provides integrity of that process. You're not just going to have one person turning a key and launching a missile, right? Checkpoints in the systems development lifecycle, testing practices, etc. And we'll get into all those details as we move into the future lessons in this particular domain. All right. How is integrity different than confidentiality? Confidentiality is the process of hiding information, whereas integrity doesn't hide information. It ensures that the information is not modified. Okay? So you can incorporate those two things and provide both confidentiality and integrity. We see that in cryptographic standards all the time. The use of, say, SHA or MD5 for integrity and AES or triple DES for encryption, and so on. All right? Now, you can have all the confidentiality you want, you can have all the integrity you want, but if the system's not available, then it's completely useless. Right? So availability is the third part of this triad. Right? The principle that ensures that information is available and accessible to users. The most common threat vector to availability is denial of service. Right? Why is denial of service so prevalent in technology today? Right? Well, it doesn't even have to be technology. It could be being able to walk into a building. Right? You know, think about it. Some group of individuals has a problem with an executive because he got busted for whatever. And so they're going to protest the organization. What do? They barricade the doors, or they block people from accessing the building, or they dissuade people from accessing the building because that people are scared to enter. That's a denial of service attack, right? It's not a denial of service attack against technology, but it is a denial of service attack, right? Well, very similar in the technology space, denial of service attack is a type of attack against availability. I'm not trying to break into a system. I'm not trying to gain access to information. I'm just simply trying to make it so that system is not accessible. Right? Most common form of attack because it's the easiest one to implement. Because you're just taking advantage of well-known aspects or properties of a system. All right? And from the technical side, we'll get into that in more detail as well. Loss of service because of a man-made or natural disaster makes sense. What are some examples of a man-made disaster? Well, we see them all the time, right? Whether it's somebody blowing up a building, or lighting something on fire, or calling in a bomb threat, whatever it might be, right? Anything that's going to disrupt service is disrupting availability, all right? We measure the criticality based on the significance of impact of downtime. All right? We're going to talk about these concepts a little bit later, MTTR, MTTF, RTO, and so on, and recovery time objective, and mean time between failure, and mean time to recovery, etc. We'll talk about all these concepts later, but we measure criticality based on the significance of impact. Right? Is it a big deal that our public web server, which houses some information about our company, is down? Or is it more of a big deal that our Salesforce portal is down where we make all our sales, right? It depends on the organization. So, and by the way, domain number 2, we talk about all kinds of concepts that relate to this as well. Identifying the criticality based on the significance of an operation to a business. So what are some availability controls? Anti-malware detection, incident management plans, disaster and business continuity plans, etc. We can't guarantee 100% availability. We can try and get as close to that as possible. And we have to implement technical controls and administrative controls and physical controls to provide that, right? For example, you don't want somebody driving a car into your building, so what do? You put up bollards, you have hills, you have, guys with big machine guns, that kind of thing, right? All right. By the way, this is how you have to think about on the exam, too. You have to think in these broad perspectives, right? We're so used to, in technology, thinking about technology, right? Thinking about the firewall or the router or the server or the host, right? But from the perspective of CISSP, you have to broaden that scope. Think about it from every angle, every aspect: personnel, people, buildings, operations, technology, etc. That's one of the big key differences to CISSP that we didn't see in some of the other certifications. So here's a pretty little picture that describes this, this triad, right? Confidentiality, integrity, and availability. Are these the only aspects of information assurance that we're concerned about? Obviously not. There are other aspects that we'll talk about as well. Particularly when we get into technical controls, we'll talk about things related to other aspects of security. All right.